The law of cosines is another theorem that allows us to tackle oblique or non-right triangles. It is similar to the law of sines in that sense that it allows us to figure out the sides and the angles of a triangle that is not a right triangle. This law is going to tackle the remaining two cases, which I had mentioned in the previous lesson. The two cases are the side angle side case and the side 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 case. So side angle side means that you know the angle between two known sides. So if you know two sides, you also know the angle between them. So this would be an example. And the other case would be the side side side. So if in any of these two cases, you will be able to use the law of cosine successfully. If it is not one of these two cases, then you know it should be the law of sines. So what does the law of cosines say? Well, the law of cosines is basically a generalization of the Pythagorean theorem. So it is basically a version of the Pythagorean theorem that holds for all triangles, not necessarily right triangles, because the Pythagorean theorem only works for right triangles. If it is not a right triangle, the Pythagorean theorem is wrong, it is false. So the law of cosines is a version of it that holds always. The Pythagorean theorem being a special case of this. Alright, so let's look at a triangle and let's explain what the law of cosines say. So, as I said, it is similar to, it is basically a generalization of the Pythagorean theorem. So it is like, if you have a triangle like this, you can think of any of the three sides as your hypotenuse, quote, quote, hypotenuse. It's not really hypotenuse because it is not a right triangle, so it is a fake hypotenuse. I probably shouldn't be using that word, but it's like the best analogy for you to understand it. So suppose that this side here, I take it as my hypotenuse. So what would the Pythagorean theorem say if this were like a real hypotenuse? It's not, but let's suppose for a second that it is. If this was hypotenuse, then the Pythagorean theorem would say that hypotenuse squared equals b squared plus c squared, right? Hypotenuse squared equals b squared plus c squared. However, this is not a right triangle, so this is not really true, and therefore we have to make a correction to this. So this is wrong, but you have to fix it. So how do you fix it? The theorem says that you can fix this by subtracting 2 times the product of these two sides, so b and c, times the cosine of the angle between b and c, which is always going to be capital A. So the angle between b and c is capital A. So this fixes it, and that is the correct version of the quote-quote Pythagorean theorem that holds for this triangle, and it's known as the law of cosines. And you can do this for any side. You can think of any side as being your quote-unquote hypotenuse or your fake hypotenuse, and apply the same reasoning and get another formula. So for example, if I think of this side as my quote-quote hypotenuse, my fake hypotenuse, then what would the Pythagorean theorem say if this was a right triangle? It would say that hypotenuse squared, so b squared, equals this side squared plus that side squared. Right? If this was a right triangle and this was a hypotenuse, that would be correct. However, this is not a right triangle, so you need to fix this because this is wrong. So how do you fix that? Well, you subtract this, which would be 2 times a times c, times the cosine of the angle between a and c. So a and c, the angle between a and c is b. Okay, so that would be the law of cosines if I choose this side as my fake hypotenuse, and so on. You can do this for any of the three sides. If I do this for the third side, I would get the third version, which would be c squared equals b squared, a squared plus b squared minus 2 times ab times the cosine of the angle between them, which is capital C. Okay, so that's what the law of cosines say. Now, I want to mention that I said this is a generalization because in the special case in which you have a right triangle and you apply it as normally, so let's draw quickly a right triangle. Let's say this is A, B, C. If I apply the law of cosines to this and I assume that this is the hypotenuse, okay, I know it is, but in the context of the law of cosines, then the law of cosines will say that this is c squared equals a squared plus b squared minus 2 times a times b times the cosine of the angle between a and b, but the angle between a and b is 90 degrees. That's a right triangle, so that's a 90 degrees. Now, if you remember, cosine of 90 degrees, well, 90 degrees is a special angle. And what is the cosine of 90 degrees? It is 0. So that means this whole thing is 0. And if that whole thing is 0, what do you get? You get c squared equals a squared plus b squared, which is indeed the Pythagorean theorem that we've known forever. So you see, the law of cosines is a generalization, and the Pythagorean theorem is a special case of the law of cosines. Special case, when the angle is 90, you get the regular Pythagorean theorem. The good news is that if you think that the Pythagorean theorem is easy, well, then the law of cosines is just equally easy because it's pretty much the same idea. So let's do one example here. He says, solve for the remaining angles and side of the triangle shown below. And this is an example of a triangle where you have a side, the angle, and the side. This is a side angle side because you know this side, that side, and the angle between them. Okay, so let's solve it. So let's find little b first off. So assuming that this is like the quote hypotenuse, you would get that b squared equals a squared plus c squared. But because this is not a right triangle, you have to fix it by subtracting 2 times AC cosine of the angle between them. And that's the law of cosines right there. And now all you have to do is plug in your numbers. Let's do it. So this is going to be b squared equals a squared, which is 12 squared. Sorry, a is 10. Let's fix that real quick. A is 10. C is 12. Minus 2 times 10 times 12 times the cosine of 30 degrees. Okay, now let's simplify this. B squared equals, this will be 100. You can put this in the calculator, but this is 100 and this is 144. So 100 and 144 is 244. And 2 times 12 is 24, and then times 10 is 240. Because multiplying by 10 just adds a 0. So 24 times 10 would be 240, and then cosine of 30. Now, you can just put this in the calculator right now. If you're just looking for an answer where you just round to, I don't know, 3 or 4 decimals, you'll need a calculator anyways. But if you wanted an exact answer, instead of a rounded answer. Then since this happens to be a special angle, we could say that this is square root of 3 over 2, and then you could, again, you don't have to do this, because I'm pretty sure that he will probably ask you to round in the homework, but let's do it. So this will be 120, canceling a 2. And now, taking square root on both sides, we get b equals the square root of 244 minus 120 square root of 3. And that would be an exact answer if that's what you were looking for. You can always give exact answers when one of the angles is a special angle. But now let's put it in the calculator and let's get around a decimal for the answer. So you could have done it before, as I said. Okay, let's do it. So this would be square root of 244 minus 120 times the square root of 3. So you get that that is 6.012811158. Remember what I told you, do not round until you're done with the problem. We're not done with the problem. We're done with finding B, but we're not done with the problem. The problem says find everything, and we still haven't found that angle or that angle, so we're not done with the problem. So that means I'm not going to round just yet. I'm only going to round when I'm about to enter the answer in the online homework system. Okay, so just copy that there and do not round. And the reason we're not going to do that is because we might need this number. If they were asking for only side B, we will be done. The problem will be over. But we have to find now the other two, these two angles. All right, how do you find that angle or that angle? There's two answers, two correct answers. You can, since now we have B, that means we have a pair of a side and its opposite angle that is known, fully known. So that means we could use the law of sines. So to find either of these two angles, you could now use the law of sines if you wanted to. Or you could use the law of cosines again, which is what I'm going to do for practice because we already practiced the law of sines. So we're here to practice the law of cosines. So, but you could do either one. If you like the law of sines, you could do it, use it now to find that angle or that one. But I'm going to use the law of cosines. All right, so let's use the law of cosines to find, let's say, this angle, which is capital A, the one opposed to little a. Okay, let's find it. Question is, what is that? Okay, so let's apply the law of cosines where the fake hypotenuse would be little a. Okay, the law of cosines would say little a squared equals b squared plus c squared. But because this is not a right triangle, we have to fix it. To fix this equation by subtracting 2 times bc times the cosine of the angle between b and c, which is capital A. And now we just plug our numbers in this equation. So we would get, you see now I'm going to use this number. That's why we shouldn't have rounded before. We need the exact, like the whole thing. If you round prematurely, the error is compounded. You might end up with a wrong answer. No. Oh, that would be, sorry, that should have been B. That should have been on the other side. So let me fix it by just writing here. 10 squared equals, fixed. 10 squared plus c squared, that would be 12 squared. minus 2 times b times c times the cosine of a. Okay, so these will be 100 equals. Now, put these two together in the calculator. So I already have that there. So I didn't erase it. Good for me. So squared plus 12 squared. Okay, let's copy all of this. 180.1539031 minus, now let's do that, 2 times 6.0128, 1158 times 12. This is 144 point, again, copy the whole thing. I know it's annoying, but we need all those decimals. We only round when we're done. Alright, now subtract 180, move this to the other side, so you have to subtract. So subtracting, we would get negative 80. So it's basically like subtracting 100 from here, but put in a negative. Put 1.15393031 equals negative, and then copy this. You see, the love signs would have been probably a little bit quicker than writing all these, but let's keep going. All right, and now finally divide. So now divide both sides by this. So if you divide both sides by that, that's going to go away from here, and you end up with negative 80.1539031. All of that divided by negative 144.3074779, which is, let's figure out what that is. The negatives are going to cancel, so I don't really even need to write them. So 80.1539031 divided by 144.3074779. Okay, so we got what? We got 0.55543832. Lastly, to get A out of there, remember how that's done, you hit it with cosine inverse. So A is going to be cosine inverse of this number. And let's see what we get. Cosine inverse of that answer equals 56.2590895 degrees. So that would be A. And now we're almost done. Now we need to figure out just the last angle. If we go back to the picture, we got that, we got that. The only thing that is missing is that. But if we have two angles, the third angle is really, really easy. It's just 180 minus this angle. C is going to be 180 minus the two angles, minus A minus B. A is this thing that we just got. B was 30, they told us. So now let's see what is C. So 180 minus 56.2590895 minus you get 93.74091049. That is capital C. Now we have everything about that triangle. So that means we're done with the problem. This is the time, now that we're done, this is a time where you would be rounding your answers right before entering them. So if they say round to 3 decimals, you would say this is 56.259. This one will be 93.741. And this one will be 6.013. Okay, so just look out for what the instructions say. Alright, if you got that and you want to try it on your own, you can pause the video and try this one. Otherwise, just wait for the third one because we're doing 3 examples. Okay, here's another one. It says, solve for the remaining angles inside of the triangle described below. And in this one, there's no picture. So it is advisable that you draw a picture. To keep track of the things as we find them. So suppose this is little a, this is little b, this will be capital C because this will be little c. That this angle would have to be capital A because it's the opposite to side little a, and this angle would have to be capital B because it's the angle opposite to little b. And we know that this is 37 degrees, and that this is 11, and this is 8. Okay, so now let's apply the law of cosines. We have, again, this is a situation where we have side, angle, side. We know 2 sides and the angle between them. The third example is the one where we do side, side, side. Alright, so let's tackle it. Starting with this side as the quote-quote hypotenuse or the fake hypotenuse, we would get that c squared equals a squared plus b squared. But because it's not a right triangle, we fix it by subtracting 2 times AB times the cosine of the angle between them, which would be capital C. Cosine of capital C. Okay, now let's plug in the numbers. We get c squared equals 8 squared plus 11 squared minus 2 times 8 times 11 times the cosine of C. 8 plus 11, let's do that real quick in the calculator. 8 squared plus 11 squared, 185. 2 times 8 times 11, 176. Now we're at the point where we could have just written, we could have done that actually here. 37 degrees. Okay, so C would be square root of 185 minus 176 cosine of 37 degrees. So let's enter this in the calculator and get the value of C. So square root of 185 minus 176 times the cosine of 37. Ooh, this is 6.666344593. Okay, so that is the value of C. Don't round yet. Okay, now let's Do it again to find another angle. So now we have little c. Do it again to find another angle, or if you like, you may use the law of sines right now to figure out either of the angles. Okay, you may do that if you want. But I'm going to do the left cosines one more time, where I'm going to just use this side as my fake hypotenuse. So that would be b squared equals the other two sides squared added together. But because this is not a right triangle, fix it by subtracting 2 times AC times the cosine of the angle between them. Good, now I plug in my numbers. 11 squared equals a squared. That would be 11 squared. 8 squared plus c squared is, I need to square this thing. I'm going to copy it. Minus 2 times 8 times cosine of b. Okay, we don't know that what capital B is, that's what we're looking for. 11 squared is 121, and then let's put this whole thing in the calculator. So I already have that number there, convenient, so square it, plus 8 squared. That is 108.440150. And now let's multiply here. 2 times 8 times 6.6663 44593. That would be 106.66 15135 cosine of capital B. Okay, now subtract, move that over here, subtracting. So let's do that. 121 minus 108.44 01502. That would be 12.5598498 equals negative 106.66515135 cosine of B. And now you divide both sides by this number, and you will get cosine of B. So this would be 12.559. There's a lot of copying in here. 98498. All that over 106.66155135. Okay, almost there. Almost. Okay, now let's divide. So I already have the numerator right there, and I have to divide by 106, no, by negative 106.6615135. So we got negative 0.117754281, and lastly, I'm gonna hit this with cosine inverse to get the angle. So hit it with cosine inverse. Okay, you get 96 degrees. 96.7625133 9 degrees. To get the final angle, you just subtract both of the angles from 180. So the angle that we're missing is capital A. So capital A would be 180 minus the other two angles. So it would be 180 minus B, which is this, minus C, which is 37. Okay, so 180 minus 96.76251339 minus 37 equals 40, 46. 46.2374866 degrees. Now would be the moment, now that we're done with the problem, now would be the moment where you would round your answers. In this case, it says round to the nearest thousandth. That means that would be tenths, hundredths, thousands. So that would be 3 decimals. Tenths, hundredths, thousands. That would be 3 decimals. So you would say that A would be 46.237. Capital B would be 96.763. And capital little c would be 6.666. That's an ugly number, but that's what we got. And here's the third promised example. This is a situation where we have all three sides. They give us little a, little b, and little c. So this is the S side, side case. If you have not tried, if you didn't try example number 2, I really recommend that you pause the video now and try this one on your own. And let's say, find at least one of the angles. Let's say find angle capital C first and see if you got that. Or maybe do the whole thing, but at least find one of the angles. Alright, so let's do it. You can draw a picture for yourself if you want to. You don't really necessarily have to. And your picture doesn't have to be, perfect either. So let's say this is my picture. Let's say this is little a, which is 20. Let's say this is little c, which is 18, and this is little b, which is 25. Okay, suppose that's my triangle. Then this side opposite to little a would be capital A. This side opposite to little b would be capital B. And this side opposite to little c would be capital C. Okay, so let's say we find capital C. Finding capital C means that when we apply the law of cosines, we're going to think of little c as a quote-quote hypotenuse or the fake hypotenuse. So the law of cosines would say c squared equals a squared plus b squared. This is not a right triangle, so we make a correction. Minus 2 times AB times the cosine of the angle between them, which is capital C. Now I plug in my numbers, and I will get 18 squared equals 20 squared plus 25 squared minus 2 times, what is A? A is 20. B is 25. Cosine of C. Okay, now we need a calculator for that. 18 squared is 324. 20 squared is 400. And 25 squared is 625. So that's 1025 minus 2 times 20 times 25 is 1000. Now move this to the other side and subtract. So 324 minus 1025 negative 701 equals negative 1000. Cosine of C would be negative 701 divided by negative 1000, which now the negatives would cancel. And I don't even need a calculator for that one. Divided by 1000 means move the dot 3 times, so this is going to be 0.701. And to get C, heat this equation with cosine inverse. Cosine inverse of 0.701, which so cosine inverse of 0.701, which is 45.4927107 degrees. Okay, this is capital C. That need to make that bigger. Okay, so this is capital C. Now you can do this one more time to get one more angle and then subtract from 180, or use the law of sines. Now I've already done the law of cosine quite enough times, so I'm just going to do it using the law of sines to figure out one more angle, because now we have one pair. We found this angle, so we have the pair of one side and its opposite angle, so we can use the law of sines. So that's what I'm going to do. So I'm going to do that for finding, let's say, capital A. Why not? Let's find capital A. So applying the law of sines, so now we're going to find capital A using the law of sines. Just for a change, you can use the law of cosines again. Okay, you would get little a over sine of capital A. So that's one pair of the side and its opposite angle. And little c over sine of capital C, which is the pair that we do know. Plugging in the numbers, we get little a is 20. Sine of A is the angle I'm trying to find. Little c is 18. And capital C is the angle that we just found. Okay, now cross multiply and divide. So what do we get? When we cross multiply, you get 18 sine of A equals 20 sine of 45.4927107 degrees. And now divide by 18 on both sides. Then you're gonna, to get capital A, hit it with sine inverse. You can put all that in the calculator right now and then hit it with sine inverse, or just do it all at once. So I'm gonna do it all at once. So when I hit this equation with sine inverse on both sides, I will get A equals sine inverse of this whole thing. Okay, it looks like a mess, but let's be careful when entering this. So sine inverse, sine inverse of 20 times sine of 45.4927107 close parentheses divided by 18 close parentheses equal. So we get that A equals 52.41049704 degrees. And finally, to find capital B, subtract 180 minus A minus C. Okay, so let's put in the calculator. 180 minus A is this. So minus 52.4104 minus C, which is that. That's 45.4927107. Okay, so we got 82.09679226 degrees. Okay, and as I said, now that we're done with the problem, now is the moment where you would round. The particular instructions in this says round to the nearest thousandth, so that means 3 decimals, so keep 3 decimals. So the answer for capital C would be 45.493. The answer for capital A would be 52.410. And the answer for capital B would be 82.097.